In the 1970s, one out of every four children were dying before the age of 5 in Bangladesh. UNICEF and the World Bank recognized that the surface water that was being consumed was infected with harmful bacteria that caused a deadly diarrhea. In order to fix this problem, they funded projects to create tube wells to withdraw what they believed was safe drinking water. Unfortunately, UNICEF neglected to test the mineral properties of this water before opening the wells. In the 1990s, thousands of people in Bangladesh were getting symptoms of arsenic poisoning, including vomiting, discolored skin, lesions on the hands and feet, and white lines down their fingernails. The issue had been called the worst mass poisoning in history. Due to the severity of the problem, the World Health Organization declared a major public health emergency for the contaminated water in Bangladesh. After researching the problem, they discovered that the people were being poisoned by the water being drawn out of the shallow wells built in the 1970s. The World Health Organization claimed that over 45% of the population had been exposed to deadly amounts of arsenic. Out of the 7 million hand pump tube wells built in Bangladesh, over half of them were supplying water with arsenic levels over 50 micrograms per liter. This amount is incredibly large considering the fact that the levels must be under 10 micrograms per liter in order to be considered drinkable in the United States. The arsenic is believed to have entered the water by certain types of bacteria that remove the arsenic from the earth and deposit it into the water. The problem is that the water is being consumed and will continue to be consumed by the people of Bangladesh because there is no other source of water in the area. Also, numerous crops are being contaminated by the water that is drawn from the wells, and these crops are being eaten by the community. It has been estimated that 270,000 people will die due to cancer caused by arsenic poisoning in Bangladesh. People affected by arsenic poisoning suffer an enormous social stigma in their community, as people in Bangladesh consider it a contagious disease or a curse. We hope to fix this major health issue by the use of iron absorption pills. By simply placing a pill into the water and letting it sit, we hope to rid Bangladesh of their poisoned water problem.
Now knowing the dangers that arsenic imposes to the general public, it is important to consider which solutions are most effective for remediation. For the purposes of being cost effective, we will be discussing a method that has proven to be successful in many research studies. Iron oxides, in its many different forms, have proven to remove large concentrations of arsenic contamination well above the EPA regulated amount. Hematite is a great example of an iron oxide with high sorptive capabilities on organic and inorganic compounds. This meter project aims to accomplish similar results with modifications to iron oxides under study. Instead of having the iron oxides and the contaminant interact with each other under an ideal groundwater setting, we will be discussing the advantages of encapsulating iron oxides in alginate solution to achieve arsenic remediation. Some of the parameters that need to be mirrored for the purposes of preserving groundwater settings faced with high concentrations of arsenic are controlling water temperature, pH levels, arsenic oxidation state, and lastly, arsenic concentration. Based on intensive literature review, the amount of iron that was used in an effective study was 50 milligrams of hematite, which was successful at absorbing 100% of 100 parts per billion of arsenic from solution. For consistency purposes, our group aims to target the same amount of iron oxide and arsenic concentrations during our efforts of remediation. Before going into detail as to how encapsulating iron oxide is beneficial for the general public, I will be briefly talking about how the capsules are created. The first step is to weigh out an amount of iron oxide. The weighed out amount of the desired iron oxide is determined by the iron's sorptive capability on arsenic. That amount is then poured into a glass vial. The glass vial is filled with 2% alginate solution and diluted water. The ratio between alginate to water in the glass vial of solution is a 2-to-1 ratio. The glass vial filled with alginate water and iron is uniformly mixed by a vortex machine and then extracted using a microliter pipette and then poured into a petri dish containing calcium chloride. The vortex machine is used to create the uniform iron and alginate distribution in the glass vial, which is vital to creating beads of the same size. After the capsules are properly incubated for at least an hour, they are tested using atomic absorption spectroscopy, which is also known as AAS. The AAS equipment is used before and after arsenic of different concentrations at ideal groundwater conditions are exposed to the capsules containing the iron oxide. The purpose of running arsenic through the AAS equipment before exposing the inorganic compounds to the beads is to accurately determine the level of arsenic concentration in the water. Once the concentration is determined, then the experiment can be conducted containing the capsules. After the experiment is thoroughly mixed and left in solution with iron and arsenic for at least 30 minutes, the capsules are removed and then the water containing the arsenic is treated and then tested through AAS. The purpose of doing that is to see how effective the capsules are at removing arsenic from the contaminated water. To conduct this remediation process, proper funding, time, and equipment is necessary. Under ideal conditions, once this remediation process works, the capsules can be deployed in large volume in real groundwater settings in Bangladesh or in any other country faced with arsenic problems. In addition,